In today's lessons, we're going to 5.4b. We've already talked about 5.4b in some regards because we have been solving radical equations, but today we're going to add in rational exponent equations. But it turns out because radicals can be written as exponents or vice versa, um, it's really the same type of problem, so it's not particularly new material. Let's first look at a comparison of the same problem solved once using radical form and then once using rational exponents. So here are both the same problem. Now you may not recognize them as both being the same, but they are indeed. Um, by definition, a square root is the same thing, so this square root symbol is the same thing as raising x plus 25 to the half power. And since those two things are equivalent, these two equations are the same. So let's go ahead and solve the one on the left using radicals. So here we would square both sides, because the radical is already isolated. X plus 25 equals 4, and then we'll subtract that 25. So x equals negative 21, and this does check. I'm not going to spend time going through that. If I have to solve in rational exponent form, I do exactly the same thing. I'm going to raise the left-hand side to the half power and the right-hand side to the half power. And when I do that, you'll notice up here I get a power to a power. And we have a rule for that for exponents, and the rule looked like this: a to the m raised to the n is a to the m times n. So it's a multiplication of a half times 2. Well, half of 2 is just 1, so it's x plus 25 to the first. We just don't show 1s as exponents. Equals 4, 2 squared, and then we'll subtract our 25. And so x equals negative 21 again. So on the left-hand side, we did it with radicals. On the right-hand side, we did it with exponents. So let's look at this example where it's just strictly in exponent form. Let's see if we can solve it. In this particular problem, the exponent is this 3/4 here. So this is like our radical term. And so just like we did with radical equations, we want to isolate that term with the exponent. So let's go ahead and we will, hopefully here, we'll subtract this 2 from both sides, giving us 2x to 3/4 equals 8. Now here comes the trick. Yes, I could raise both sides to the 4th power, and when I raised them both to the 4, you'd multiply here and the 4s would cancel, and you'd still have this 3 here to deal with. But instead of doing that, the trick is to raise it to the reciprocal power, which means since we have 3/4, we are going to raise it to the 4/3 on both sides. And the reason we raise it to the reciprocal is because a over b times its reciprocal, b over a, is always just equal to 1. And you can see if you were to multiply them out, you get ab over ba, but those are essentially the same thing. Numerator is the same as denominator, so it's just equal to a 1. And so that's the situation that we've created right here. The 3 times 4 is 12. The 4 times 3 is 12, and 12 over 12 is just 1. So that radical is gone, giving us just this 2x equals 8 to the 4/3. Now I'm going to step off to the side here to show you how to deal with that 8 to the 4/3. Okay, the 3, the denominator of your exponent, remember, that tells us the root, to use. So we're going to be doing the cube root of an 8. And then the numerator, the 4, tells us to raise that answer to the 4th power. But the cube root of 8 is just 2, so it's 2 to the 4th, which is 16. So our equation quickly becomes 2x equals 16. You could get out a calculator to evaluate that 8 to the 4/3, And if it comes out to be nice, in this case it did, it came out to be a 16, it'll tell you that. Last step, let's divide by 2. And there we go. X is just 8. Let's run through and check that real quick. So 2 times 8 is 16 to the 3/4 plus 2. That's the left-hand side. Let's see if it does indeed equal this 10 on the right. Well, this is the 4th root of 16. The 4th root of 16 is 2. So it's a 2 cubed, because we haven't done anything with that 3 yet. Plus 2, and that's an 8 plus 2, which is 10, so it checks. And therefore, x equals 8 is our solution. So the key thing is, isolate the x term, and then raise it to the reciprocal power. Let's take a look at this one. Here's the term with the x in it, and it's all raised to the 1/2 power. And so the reciprocal of a half, I didn't have to isolate it because it was already isolated, is 2 over 1. Now 2 over 1 is just 2. I'm just showing that it is the full reciprocal. And 1 over 2 times 2 over 1 is just 1, so x plus 30 equals x squared. Now this is quadratic, so I'm going to get it equal to 0. I'm going to move the x over by subtracting. Negative x squared minus x minus 30 equals 0. And again, we looked at or talked about multiple ways to solve quadratics yesterday. I'm going to solve this one by factoring x and x. Oh, 3 and 10 won't work. In fact, I'm not seeing any factorization that works, but that's all right. Let's go ahead and use the quadratic formula on it. So a is, let's highlight these, 1, and b is this -1 out in front of the x, and c is this last term, -30. Let's write down the old quadratic formula here. X, in this case, because that's what the variable is -b. Plus or minus square root b squared minus 4ac. All over 2a. So let's just start substituting here now. Be careful here. We want the opposite of b. Well, b is -1, so the opposite of -1 is just 1. So it's 1 plus or minus. We're going to square b in our head. So b is -1 times -1 is just 1. Minus 4 times a times c. All over 2 times a, but again, a is just 1, so 2 times 1 is 2. So let's figure out what the discriminant is. The discriminant is what we call the radicand when it's solving the radical or the quadratic formula. So this is referred to as the discriminant. So -4 times 1 is -4 times -30, so that's going to be plus 120 plus 1, so 121. So apparently this would factor, because the square root of 121 is just 11. Now be careful, this does give you two answers here. Okay, the first one is 1 plus 11 over 2, and the second one is 1 minus 11 over 2. That's 6, and that's -5. So had I been more awake, I should have factored this as x times x, 5 times 6, negative, positive, and that would give me -5 and 6 for my solution. So either way I do it, I do come up with those same two answers. Now let's run back to the very beginning, and let's check to see if both of these answers indeed do work. Oops, I am going to step back here just for a second. So if you want to get all of that in one screenshot, you can. And now I'm going to go ahead and check my answers. So let's check the 6 first. That'd be 6 plus 30 to the half power. Does that equal 6? That's 36 to the half. This is the square root of 36, so 6 equals 6. Yes, 6 does check. Let's check on the negative 5 now. Negative 5 plus 30 to the half power. Does it equal negative 5? This is 25 to the half. Square root of 25, though, is just 5, not negative 5. And therefore, they do not equal each other. So we cross that out, and our only solution is x equals 6. Cross out those negative 5s. Got one more example. Very similar. You can see the radical is isolated on the left-hand side. Let's raise it to the reciprocal on both sides. Again, these make 1 when you multiply them. This is the cube root of 8, which is 2, and then we have to raise it to the 4th power. So that's 16. Subtract our 2. X is 14. Let's check it. 14 plus 2 raised to the 3/4 power. So I've just substituted in to the original equation up here. 16 to the 3/4. That's the 4th root of 16, which is 2. 2 times 2 times 2 times 2. And I have to cube that, and so it's 8. So the left side is 8. Does that equal the right side? Yes, it does, because the right side is 8. Therefore, x equals 14 is our solution. Not too bad. Okay, the first two are just straight up radical equations. You can see the radical in number 1 is already isolated. The radical is already isolated. You're just going to have to square both sides. Be careful when you square. Notice this is a binomial, so you're going to have to write it twice and multiply it together. Then we move on to these new ones. Remember, we do want to get the x with the exponent isolated, so like in number 3 here, you'd want to divide away that 2 first. And now raise each side to the reciprocal power, 3 over 2. So very similarly, number 4, you're going to want to subtract that 3 first. 5, you're ready to square both sides. And 6, you're going to have to move that 2x over first. And once you've moved it to the right-hand side, then you'll be able to square both sides. And that should get you off and running on your homework.